So if I graph this second equation, and so I'm going to color code mine. I'm going to number them because when I get lots of equations on here, it becomes a little bit difficult. And I'll graph 3 or 4 on one screen. So the second equation I'm going to graph is x plus 2y equals negative 4. Well, what's the x-intercept? All right, so if my x-intercept is negative 4, that's negative 4, 0. So negative 1, 2, 3, 4, 0. What's my y-intercept? Negative 2, so that's 0, negative 2. And if I'm counting, I'm going down 2 over 4. So what's my slope? 1/2. So I can graph a lot more points. Down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. And I want to graph as many as I can because I'm trying to find the intersection between two graphs. So if I want to know their solution, I want to know where they have the same x and the same y value. Well, that's this point right here. So I'd go over 2, down 3. So their solution is the point 2, negative 3. That is the point they share in common. If they share one point, the answer is the point they share. If they share infinitely many, the answer is infinite solutions. If they share none, the answer is no solution. So this is an example of a consistent and independent system. So now you're going to graph one. I don't care if you get it y equals mx plus b form. Actually, the next one's going to be much easier in y equals mx plus b. But you're going to graph the two equations. So on your paper, in as much detail as you can muster, graph 9x minus 6y is equal to negative 6, and 6x minus 4y is equal to negative 4. So hopefully you got what I got. Okay? We want fraction form if we're doing slope. We don't want decimals. So 3 over 2, not 1.5, because I can count up 3 over 2. It's hard to count up 1.5 over 1. So did you get that they were exactly the same equation? So when I graph them, they have the same slope, same y-intercept, they're exactly the same line. In standard form, I just gave them in a different format. It's the only thing that happened. This first equation wasn't in standard form because they all had a common factor of 3. All right, so if I'm looking at this equation, what kind of solution is this? What is the solution? Yep. Infinite. They share every point. They don't share no points, they share every point. So infinite solutions. And you may want to write a note to yourself, infinite solutions when they're the same line. Infinite solutions, they share every point. And is this consistent or inconsistent? Consistent, so that means there's an answer. Is it independent or dependent? Dependent, because one line is the same as the other, they're dependent. Questions? So how's about you try another one? Did I write the next one for you? All right, so it's already on there. You can try the next one on your notes. So as you solve the equations, before you graph them, make sure they're the same as my equation. If not, raise your hand and I'll help you. At the lines. So they're parallel lines. They have the same slope, but different y-intercepts. So they're not the same lines. So even if I didn't graph them, if they have the same slope and different y-intercepts, they're parallel. So they'll never touch. So what is my answer? So my answer is no solution. They'll never have an answer where they touch. And the only thing that gives me an answer of no solution is an inconsistent system. So if I graph the first one in black, it has a y-intercept of 0. And I go up 1, 2, 3, 4, 5 over 2. Or down 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That's negative 5. Left 2 is a negative 2. My board is constantly out of calibration today. And then if I graph the blue, I'm starting at negative 5. So 1, 2, 3, 4, 5. This is my y-intercept. And I'm counting up 5 over 2. Up 5, 1, 2, 3, 4, 5 over 2. So there is no solution between them. So that's kind of a recap of everything you've probably already done, right? You didn't call them inconsistent or consistent, but you've graphed and found the points of intersection before. We can even find these on our calculator. So your calculator can assist you. if you grab a graphing calculator, we'll do the next one. We'll do the next one. Okay, so where do we take this from Algebra 1 to Algebra 2? We take it to word problems. Algebra 2, one of the really cool things we get to do is start applying this to other things that you might see. If you want to go to school and study business or finance or marketing, this is where you're going to see this kind of stuff. So in this situation, we have a service club selling copies of their holiday cookbook to raise funds for a project. The printer's setup charge is $200. So just for saying that they're going to make your cookbooks, they set up their templates, it's $200. Each book is $2 to print. The cookbooks will sell for $6 each. How many cookbooks must the members sell before they make a profit? So now we've got some words you've probably not learned before. We're talking about profit, we're talking about money coming in and money going out. So I need to show you a couple of things that maybe you've never seen. The first is how we calculate profit. Profit is equal to the revenue you make minus your cost. Revenue is money coming in or money you make. And costs are money going out, also known as expenses. So if we talk about you and you've got a job, what your paycheck shows is your revenue. That's how much money you brought in. And then what you spend is your cost or your expenses. That's the money going out. Now, if I make more money than I spend, so if my revenue is bigger than my cost, what kind of profit do I have? What kind of numbers? Positive. I've made a profit at the end of the day. That's really good. Okay? Or I've saved money. I may actually get to retire or go on vacation, or if my car breaks, the whole world doesn't end. However, if I spend and make exactly the same amount, every dollar I make, I spend, then what happens if my car goes kapooey? I'm out of luck, right? Or I can't go on vacation, I can't afford to retire, I'm in a big pickle. So I don't want that to be just breaking even, which is what we call that. And then, of course, we run into the other situation, which is where a lot of America sits. What happens if my costs are more than my revenue? I am in debt. I have charged up a credit card, and I owe lots of money to somebody else. And they're not happy with that, and they want it back. Okay? So what your goal, you want to know how much we sell before we make a profit. We're going to do that by doing what's called a break-even analysis. When we say we're breaking even, we mean our profit is exactly zero. We didn't make any money, but we didn't lose any money. Okay? If my profit is zero, what do I know about my revenue and my cost? They're exactly the same. Look at the equation. If this profit equation is going to be equal to zero, if this is zero, then what do I know about revenue and cost? They have to be the same. So in this situation, revenue will equal cost. And that's how we're going to do our break-even analysis. We're going to graph revenue, and we're going to graph cost, and we're going to see where they're exactly the same. On a graph, what do we call that? Their intersection. If I want to see where they're exactly the same, we call that an intersection. I'm going to see the place the graphs cross. So I've given you a graph. I need a little more room for my graph, so we're going to go over here. I'm going to add a graph to my paper. And we are in the first quadrant only, because here's how we're going to graph it. Our y-axis is going to be money, and our x-axis is going to be number of cookbooks. So when we write our equations, we're going to define our variables. So every time I use an x, it means number of cookbooks. And every time I see a y, it means money. Because the revenue I make, well, that depends on how many cookbooks I sell. My cost, well, that depends on how many cookbooks I sell. So my money, whether it's revenue or cost, depends on cookbooks. So we're going to write one equation for revenue and one equation for cost. So our revenue is good. That puts us in the black, so we'll use black, revenue. So the revenue or money we make is going to be $6 for every cookbook. So $6 times the number of cookbooks. There's my revenue. Money equals $6 times the number of cookbooks. That's how much money I bring in for selling cookbooks. Well, yeah, but we're going to graph revenue and cost and see where they intersect. Now, my costs, I'm going to do those in red. So make Counting, red means loss. So my cost, my Y is my money. So my money that I spend on cost is $200 just to set up everything, plus $2 a cookbook. And we're going to graph them on the same axis, and we're going to see where they intersect. Now, if I'm looking at those two equations, my y-axis has to be at least up to what? 200. Because otherwise I won't see this red graph at all. So, I don't know, what do you want to count by? 50s? So 50, 100, 150, 200? Now my x-axis is going to be number of cookbooks. If I am going to the trouble of producing and selling a cookbook, do I want to sell 1, 2, 3, or 4? No. So I'm not going to count 1, 2, 3, 4. Maybe what do I want to count by? 10s, 20s? I don't know. We'll count by 20s just for fun. 20, 40, 60, 80, 100, 120, 40, 60, 80. Here's 200 cookbooks. So I'm going to graph the black line first. What's the y-intercept? No, the black line. Revenue. What's my y-intercept here? 0. So I start at 0, 0. Now, if I look, I'm only graphing the first quadrant because my x-axis is number of cookbooks. I cannot make a negative number of cookbooks. Not possible. And my y-axis is money. It's either money from cost or money from revenue. But either way, it's the money I'm spending, and I can't spend a negative amount of money. I can make a negative profit, but this is the money I'm actually spending or taking in, and I can't spend or take in a negative amount. I can spend more than I make, so overall I'm at a loss. But I actually can't go to the store and buy things with negative amounts of money. So I'm only in quadrant 1. Now, if I want to count my slope, what's my slope? 6. So according to this, I would go up 1, 2, 3, 4, 5, 6 over 1. But be careful, don't do that. Why not? Because I really am counting by 50s. So if I want to go up 6 over 1, I just did up 50, 100, 150, 200, 250, 300. And I went over 20. Is 300 divided by 20 the same as 6 divided by 1? So if my x and y axes are scaled differently, I cannot just count slope like I always do. So you may want to write a note to yourself. If x and y are scaled differently, be careful of slope. So 30 divided by 20, that's 15. Or 30 divided by 2, sorry. 300 divided by 20. So that's not going to work. What else could I do? So if I multiply 6 by 20, I've got 120 over 20. But I can't count 120 on my y-axis. So if I multiply by 50, I've got 300 over 50. I can do that. Oh, no, not really, I can't. Because my x-axis, I'm counting by 20s. So, I mean, I could say up 50, 100, 150, 200, 250, 300 over 20, 40, 50. But I'm estimating a point. I could. Or can I just make a table? Right? If I don't know how to graph an equation, I go old school. And if I kick it old school, I'm making a table. At 0, there's 0. All right? So maybe we already said we want whole numbers. Ooh, at 100, there's 600, right? If I have 100 for x, that's 600 for y. So here's 100 up, 50, 100, 150, 200, 250, 300, 350, 400, 450, 500 is right there. 550, here's 600. Somehow I've got to be able to graph it, whether it's making a table or figuring out the slope. And there's my line. So this line means revenue. That's how much money I make. So everywhere I graph that line, that's the money I'm bringing in. If I read it from left to right, the more cookbooks I make, the more money I bring in, we're good. Now we're going to graph cost. What's my y-intercept for cost? What's my y-intercept for the cost equation? 200. So there's where I make my little dot. And what's my slope? 2. So I run into a problem again. So 2 over 1, how else could I graph that? I go up 100 over 50, right? If I multiply the top and bottom both by 50. So I could go up 50, 100 over 20, 40. Oh, look. Let me share that point. Up 50, 100 over 20, 40. Here's 50. I've got to be real careful when I'm drawing that. So here's the line. Oh, my board is not calibrated. These are my costs. Now, if I do a break-even analysis, exactly where they touch, my revenue and my cost are equal. So right here, at this point, this was 50 cookbooks and $300, right? So when I sell 50 cookbooks, I make $300 in revenue and I have $300 in expenses. What is my profit? 0. I've made nothing, but I broke even. This is my break-even point. Break-even point. This is where my profit is equal to 0. No, 300 was my money. Right, the question asks, how many cookbooks must I sell? So 50 cookbooks to break even, 51 to make a profit. So the question is, how many cookbooks must I sell to make a profit? 51 or more. 50 breaks me even, 51 or more makes me a profit. Now, here's the really cool thing about doing this graph. The left part of the graph, my costs are greater than my revenue. When my costs are greater than my revenue, in here I've made a loss. I've suffered a loss. Mm-hmm. I can write a profit equation, so that's what you're doing there. You're writing a profit equation. So then what would I look for if I graphed that? No, hold on. If I wrote a profit equation, profit would be my revenue minus my cost. So that would be my equation. So I'd have 6x minus 2x minus 200, or 4x minus 200. So when I graph that, my y-axis would be profit. My x-axis would be number of cookbooks. I'd only have one graph. So when I graph this, what would I be looking for? Because my graph would look like that. So where on my graph, what would I be looking for to solve this question? My question was, how many cookbooks must I sell to make a profit? So on that graph, what would I look for? When y is 0, I've broken even, right? Because this would be profit, and this would be number of cookbooks. And so I'd look for this point, because that would tell me how many cookbooks to break even. Anything more, this would be profit. Anything less, this would be a loss. Here I'm doing the same thing, but I'm doing it with a system of equations, so I'm writing 2 equations. There's 2 different ways of doing the same thing. You can do either one. But you need to be able to read your graph and know what I'm asking you. Because like here, I could say anything below 50 cookbooks, I've made a loss. Anything above 50 cookbooks, my revenue is greater than my cost. When my revenue is greater than my cost, what do I make? So this is profit. And so in college, in a collegiate business course, you'll look at these break-even graphs. And they will ask you for break-even point and profit, and they will ask you for loss. And they do equations like this, a system of equations, in kind of an intro class. Now, we can graph this on a graphing calculator. So let me show you how to do that. Let's go to y equals. All right, if you have a calculator in your possession, reset it. Now, if we want to graph something, where do we go? Y equals. So I'm going to go to y equals, and I'm going to graph 6x, my revenue equation. And then I'm going to graph in y2, 200 plus 2x. Oops. Now, if you have a new operating system, your calculator will graph in color, and you can tell that because there will be colors over here next to y1, y2, y3. Mine on this computer is old, so I have to kind of make it graph in different ways. So what I can do is sit on y2 and hit enter, and it'll graph for y1 as a regular line, and y2 will look like a Sharpie marker. It'll be kind of thicker. And so if I hit graph, what happens? I see how many equations. Where's my other one? It started where? Where did my cost equation start? 200. A normal viewing window on the y-axis goes up to 10. So this is like if you hear noise down the hall and you're at a hotel and you look out the little peephole, you can't see what's going on down the hall. Or if you're looking out your front window and you're trying to figure out what's going out a block away, you can't figure that out. Your window's too small. So you have to step outside the yard or open the door and look around more. It's the same thing here. I'm through a very small viewing window. Part of my graph is way up here. It's above my window. So I have to step back and make my window bigger. So to do that, we're going to click on window. And this is where I need you to think. What did X stand for in this problem? What did X mean? Number of cookbooks. Can I sell a negative number of cookbooks? So my lowest X is going to be a 0. Hit enter. It'll take me to my maximum. Do I only want to sell 10? We just solved the problem. How many did it take to make a profit? 51 or more. So maybe I'll want to go maybe to 100. Now, I like the calculator and all, but I really don't want it. This X scale tells me what I'm counting by on my x-axis. And if I count by 1, it's going to show me every little tick mark from 0 to 100. So I can count by 10s or 20s or 15s or 5s or whatever I want. Now, Y was money. It wasn't profit. It was either revenue or cost. It was just plain money. So I can't have negative money. I can have negative profit, but that's not what I graphed. I graphed money. So I can't make negative money. I can't spend negative money. So my smallest Y value is 0. And we need to see at least to 200 and beyond. So maybe I'll go to, I don't know, 500. And if I'm going to do that, maybe I want to count by 50s, 30s, 25s, I don't know. And now when I change my window, and each problem is going to be different. I'm going to have to think through each window on each problem. All I have to do is click graph, and it will graph these two situations in my new window. So there's my revenue, there's my cost. So right here is where cost and revenue are equal. Over here, my costs are higher than my revenue. That's a loss. Over here, my revenue is higher than my cost. That's a profit. Now, if you're doing a profit equation, your graph is going to look different. You're going to have one graph. If you write both of these in one graph, you're solving with substitution and elimination a little bit. You can do that. Now, I want to find where these two intersect. My calculator will do that for me. If you see above table, do you see where it says calc? That'll have my calculator calculate something for me. So I'm going to go second table. What do I want it to calculate? The intersection. That's where they touch. That's where they're equal. That's what I'm looking for, is where they intersect. So I'm going to pick intersect. So don't memorize, always hit 5. Just look at it and go, oh gosh, what do I want? Intersect. I'm going to pick intersect. Now, the calculator asks me 3 questions. The first is, do I want the answer on just the first curve? No, I want them to intersect, so I just hit enter. Then it says second curve. Nope, I hit enter. My favorite question is guess. If I wanted the calculator, I can guess. I don't want the calculator to guess. I'd like it to give me an answer. So I hit enter again. Be careful, though. People who are impatient just slam the enter key 10 times, and then it will erase the answer. So if I hit enter again, the calculator will find the intersection. It says intersection x equals 50, y is 300. 50 cookbooks makes me $300 in revenue, and I have $300 in expenses. But if I keep clicking enter, it erases it, and I have to start back over. Second, trace, number 5, enter, enter, enter. Question. So you should be able to do those. Are we good? All right. So aside from doing systems of equations, we also do inequalities. So we're going to skip in your notes past the next 2 word problems to example 7. Now, if I have an inequality, what do I have to do on inequalities? Shade. And I have to remember solid line and dashed line. So I need to know that if it's greater than and equal to, less than or equal to, these are solid lines when I graph them. If it's just greater than or less than, these are dashed lines when I graph them. So you may want to make a note to yourself. On inequalities, we always shade. So what I'm asking for in a solution to a system of inequalities is I want you to shade both and tell me the region where everybody's happy. So here I'm not ever going to have one solution. I will have infinite solutions. So how do I identify what the solutions are? It's my shaded region. It's any answer within the shaded region. So the first equation is pretty easy. What's my y-intercept? -3. 1, 2, 3. There's my y-intercept. What's my slope? Up 2 over 1, up 2 over 1, up 2 over 1. There's my equation. Now, I have y alone, so if I have y alone, I can think about this. I don't necessarily have to do a test point. So there's my graph. It's a solid line, and I want where y is greater than that line. If y is alone and I want greater than that line, where does that usually mean? Top, above. So if I wanted to double check that it was really above, I could check the point 0, 0, if I could calibrate a board. 0 is greater than or equal to 0 minus 3. So is 0 bigger than or equal to -3? Yes. So the region that I'm going to shade is above this line. It's almost uncanny that we already graphed these, and now we're graphing more than one on an axis. It's almost like I planned it. We learned to graph them first, and then we went back and graphed multiple ones. See how we do that? See why it's really important to not miss a lot of class? Because then you miss the first time we did it, and you get to struggle forever. All right, so now I've got to graph the second equation, which has a y-intercept of 2, and a slope of -1. So down 1 over 1, down 1 over 1, down 1 over 1. And these are inequalities. They're not equations, so I won't have one answer. And what kind of line do I have now? A what? A dashed line, dotted line, right? And I want everything y is less than that line, so that should be below. If I test the point 0, 0 is 0 less than 2. So now I'm going to shade below. So my answer is the region that is both above the solid line and below the dashed line. So a highlighter is a really good idea here. This is my answer. It's below the dashed line, but above the solid line. So if you have a highlighter or a third color, if you want to do these in 2 colors and go put your answer in a third color, make it very visible what your answer is. Anything in that region is an answer. I can't list every point in that region because there are an infinite number of points. Now, I don't have to shade each one separately. I can graph each one, and then I can look and go, okay, bigger than this and smaller than that becomes that region that's left. All right, so if I want to be greater than 6, y is greater than -6, that's above this blue line, and I want to be less than or equal to 3x minus 3, that's above or below the black line. So if I need to be above the blue and below the black, my answer is in this region right here. Did everybody get that answer? Questions? All right, so I need you to practice a couple of these. Did I do a different one? I did example 8. No, no. I have a different example in my book, in mine. Do you not have one before this? Did we skip one in your notes? Oh, we did that one. I was saying this one. Sorry. I thought we, no, I know. I thought we skipped the one previous to this in our notes. All right, so you're going to do another one. What do you notice about these 2 equations before you start? They have the same slope. What else do they have? Different y-intercepts. So they are? No, I didn't type this one. You have to write it. All right, so this is our next one. Write these 2 equations down and graph them and shade the answer region. Because now, even though they're parallel, that doesn't tell me anything about their solution because it's an inequality, not an equation. So I'm going to graph both lines. They're going to be parallel, and I'm going to shade the region that makes both of them happy. If I'm looking for a system of inequalities, both of them have to be happy. Mama's got to be happy, and Daddy's got to be happy. So the first one has a y-intercept of 1, and a slope of negative 3, 1, 2, 3 over positive 1, 2, 3, 4. Or up 3, negative 4, either way. And this is a solid line. And the other one has a y-intercept of negative 2 and a slope of 3/4. Oops, negative 3/4. So I can graph this line. They're both solid. So if mama's got to be happy and daddy's got to be happy, this first line here I want to be greater than this first line. So that's up here. And I want to be less than the bottom line. So where am I both greater than the top line and less than the bottom line at the same time? Nowhere. So what does that tell me? No solution. Now, does that mean every time they're parallel there can be no solution? No. I could have parallel lines. The solution could be in between them. I could have parallel lines where I have to be greater than both, so my solution is just up here. I could have parallel lines where I have to be less than both, so my solution could be just down there, or I could have no solution. So as we get, instead of memorizing all the possibilities, right, as we get to each one, you've got to check it and think about it. So why don't we graph another parallel line equation? This one. So the solution region is where both graphs are happening. Triglycerides and cholesterol. And so you're a doctor here. Medical professionals recommend that patients have a cholesterol level below 200 milligrams per deciliter and a triglyceride level below 150 milligrams per deciliter. Write and graph a system of inequalities that represents the range of cholesterol and triglyceride levels. So let's let our triglycerides be X and our cholesterol be Y. So these will be triglycerides, and this will be cholesterol. Can I have a negative amount measured of triglycerides in my blood? No. Can I have a negative measure of cholesterol? No. I can't have negative. Like, I can't measure a negative. I can decrease my cholesterol. I can increase my cholesterol. I can have a small cholesterol, but I can't have a cholesterol level of negative 465. It doesn't mean anything to me. So my triglyceride levels, I want to write 4 inequalities. So the very first one is pretty easy. What does X have to be? Less than what? So X has to be less than 200. And it has to be greater than 0. So I actually can graph those separately. I'm going to graph X is greater than 200. That's what I meant. So if I graph Y is greater than 0, that's everywhere along this line Y is equal to 0. Oops, I need it to be a dashed line. So where is Y greater than 0? Everywhere above that, right? So here's Y is greater than 0. It's all the stuff above. Now, what do you want to count by on your Y-axis? 50, 50, 100, 150, 200. And Y has to be less than 200. So this is a dashed line at 200. So Y has to be greater than 0, less than 200. It's all the region then in here between the two. I'm not shading it yet because I have 4 lines I'm going to graph. So there's the first 2. The other 2 are going to deal with triglycerides. Triglycerides, my X's have to be greater than 0. So everywhere along here, X is equal to 0. So greater than 0 is here and to the right. And my X has to be less than what? 150. So maybe what do I want to count by on the X-axis? 50, 100, 150, right? So everywhere along here, X is 150, and I want less than 150. So I want greater than 0, less than 200 in cholesterol, greater than 0, less than 150 in triglycerides. This is the region that makes all 4 of those inequalities happy. Now, physicians don't necessarily graph these, but a lot of times drug companies and pharmacists, right, get tables, and the table looks something like this. So your doctor or your lab runs your results, and then they look at it and they're like, all righty, Billy, you're in here. You are right in this blue shaded region. It's right where we want you to be. You have a normal range of triglycerides and a normal range of cholesterol. Thumbs up. See you at your next checkup. So this is good. Ooh, better yet, this is good. Now, over here in this bottom right corner, what's happening? I've gone over on my triglycerides, but I'm okay on cholesterol, right? So tri is too high. Cholesterol is okay. So maybe we watch or monitor, maybe we give you medication for the triglycerides, but you're doing okay on cholesterol. Right? So we're outside of the right region for triglycerides. We're okay for cholesterol. Now what happens in this region up here? I'm within the 150 for triglycerides, so triglycerides are okay, but I'm outside of that 200 range for cholesterol, so the cholesterol is too high. So I got bad cholesterol. They're going to put me on a diet. I don't have to eat Cheerios according to the commercial, right? Kid brings his dad Cheerios, brings down your cholesterol. Isn't it Cheerios that does that, the commercial? Oh, yeah. Now, there's one other part of the graph. That top right corner. What's going on here? This is a sad, sad day, right? Your tris are high, your cholesterol is high. You are never going to eat any of the foods you like again. Ever. Chicken fried steak is not happening in your world ever again. Questions? These are cool problems. They actually apply to things you might want to do. You're shaking your head no. I did not see that. All right, last one. If I can get it to go to the next screen. Go one more, go one more. All right, I'm going to give you your very last one on your notes. You have it typed. I don't know why it's not on mine. We are going to graph 2x minus y is greater than or equal to -1. And we're going to graph x plus y is less than or equal to 4. And we're going to graph x plus 4y is greater than or equal to 4, all on the same axes. And then we're going to answer questions that follow, which are, where do all of these lines, they form a figure. When I graph 3 lines, they form a figure. I want to know the coordinates of the vertices. So the little corners of the figure, I want to know their coordinates. And I want you to shade the feasible region. So I'm going to graph it in color with you. Now, if I'm trying to shade an inequality, graphing with x and y intercepts is a little bit harder because I always have to have a test point. If I get y alone, I can know above or below. But if it's not in y equals mx plus b, I can't just look at it and go greater than, less than, and know where to shade. So for an inequality, I need y equals mx plus b unless I want to do a test point. So on the first equation, we're going to get y equals mx plus b all by its lonesome. What am I going to do first? Subtract 2x. What I do to one side of the inequality, I do to the other. I'm going to bring down the inequality sign. Negative y is greater than or equal to negative 2x minus 1. What's happening to y? He's currently being multiplied by negative 1. How do I undo that? Divide by negative 1. What I do to one side, I do to the other side. Those will cancel. When I multiply or divide by a negative, I flip my sign. A negative divided by a negative is a positive. A negative divided by a negative is a positive. So I'm going to graph y is less than or equal to 2x plus 1. So that should be shaded below less than or equal to. My slope is 2, up 2 over 1, up 2 over 1, down to left 1, down to left 1. And we said this is a solid line. So there's my first graph. I want less than. Which way is that going to be? Below, y is below 2x plus 1. So I'm just going to wait a minute and shade mine in a minute. I just know that I want down here. I might even like, put a little dot or something so I know it shades this way. So I remember that. All right, let's graph the red one. Now, if you want to graph the red one with x and y intercepts, we could. What's the x-intercept? 4. And what's the y-intercept? 4. And so the slope, if I go down 4 over 4, is so negative 1, down 1 over 1, down 1 over 1, down 1 over 1. So I can keep doing this. Easy peasy. My only predicament that I run into is shading. I wanted the corners of where they meet. Obviously, they have this point in common, so that's 1, 3. So there's the coordinates of one vertice. But if I want to shade, I'm shading, I don't know where, because y is not alone. So if I test 0, 0, is 0 less than 4? Yes, so I want to shade below. So I want below that line and below that line, so I'm in this little upside down absolute value region. All right, last one. I'm going to graph x plus 4y is greater than or equal to 4. If I want to get y alone, what do I have to do? Subtract x. 4y is greater than or equal to 4 minus x. Now what? Divide by 4. What I do to one side, I do to the other. Y is greater than or equal to 1 minus 1/4 x. So what's my y-intercept? 1. What's my slope? First of all, they share this point, 0, 1. I now know another point. And my slope is negative 1/4. So down 1 over 1, 2, 3. Oh, look, they share that point, 4, 0. Up 1, left 1, 2, 3, 4. And now I have this pretty little line. So I know I'm below that line and below that line, and I want to be what? Above this line. So my region that works is that little tiny triangle in here. Now, could you do this on your graphing calculator and find the intersection? You can. But in order to put in your graphing calculator, they have to be in y equals mx plus b. So read those to me as I show you one other predicament with your graphing calculator. We know, let's go over here. So 1 plus 2x, was that right? 1. Are these my equations? Am I crazy? Is that the first one? Thank you. And then 4 minus x? So 1 minus 0.25x. All right, so when I go to graph these, first of all, I'm in a crazy window right now. So I'm going to click zoom, and I'm going to go to standard, my normal zoom window. So that's on my calculator 6. So there's one, there's another, there's another. So I can find the intersection of any 2 points using second trace. So if I go second trace, number 5, enter, enter, enter. There's my, what I told you not to do. It's my uncalibrated board. It makes this a nightmare. You see where I'm pushing? I'm pushing here. That's not where, okay, so 1, 3 is my first point. So I've got that. Now, if I want to get to another point, if I just start over a second trace, it's going to keep giving me the same point, right? It's like a little kid and you did something, everybody said, good, and then they just keep doing it again and again and again and again, and you're like, that's the same thing. It's like, you liked the point I found, I'm going to keep finding the same point repeatedly. If I wanted to find a second point, I have to go second trace, pick intersect, and now I have to use my little arrows. So I have to somehow get it closer to the other point I want. Thank you. So now it's down here, enter. Oh, wait, it jumped back up where I don't want it. So I have to get it back down where I do want it. Enter, enter, and then it'll find the next point. So I have to keep telling my calculator where to go. All right, so you do not have a quiz next class. Okay, you don't have a quiz over just 3-1. After this, we're going to solve by substitution and elimination. So when I see you on Tuesday, we'll do substitution and elimination. So we'll solve them by hand. Please know that on your quizzes and tests, you probably will not have a calculator for much of the substitution elimination. And then we will solve 3 and 4 systems of equations the next couple of days. So you'll have an x, a y, and a z, or maybe an a, a b, a c, and a d, and you'll have to find all the variables by hand. So on your homework, omit numbers 11 through 14. You don't have to do those.